Have you ever had problems sitting in a bar trying to talk to your friend, but all you can hear is background noise from the bar? Well, guess what? You're not alone. All modern embedded systems face the same problem. These systems have to measure things that they get from sensors and then operate on them. So they might be measuring temperature, voltage, current, you name it. But these end up often being noisy. And what I mean by that is if you get a signal like this, where the blue line is the actual signal, after noise is added, you get something like the red line. And this doesn't really tell you the trend. So how can you extract the blue line out of this red signal that you're getting? Well, to do this, think about how you would report somebody's performance in a class, right? If each of these points are basically their results in an exam, you're not going to just look at one and say, oh, well, they have topped the class. You're going to look at the overall trend. You'll sort of average it and try to predict how they have performed. Well, we do the exact same thing here. So let's zoom in on some portion of this. So here, if you see, I have multiple data points, and each data point is basically nothing but a sample that the sensor has measured at one time point. So let's say this is at 5 milliseconds, this is at 10, 15, 20, 25, and so on. So we basically collect a bunch of these samples together and we average them. In this case, you can see that some of these are above what you know is the actual signal, some are below, so the average is sort of going to cancel them out. And once we've computed this, let's say my window size consisted of 7 samples, then I'm going to move this window forward and measure the next 7 samples together, and then the next 7, and so on. This process is sliding this window, so it's called a sliding window average or the moving average, and it is the simplest sort of filter out there. These class of filters are called finite impulse response because all they rely on is just inputs. So you only look at the raw data to decide what the filtered value should be. But there are other class of filters where you not just look at the raw data, but also the output from each of these windows or the filtered values that you've generated from the previous time steps. And this process is used in all sorts of systems, whether it's your automotive cars, self-driving vehicles, you have robots, power systems, you name it. Share this with your fellow nerds and geeks.